All right, this is lesson 8.02 on balancing equations. We balance equations so that we can satisfy the law of conservation of matter. Matter cannot be created or destroyed. It can only change forms. If we look at this equation, we have one zinc, and over here we've got one zinc, but on this side we've got one chlorine, and here we have two. Here I have one hydrogen, and here I have two. So I've created matter, and that's not allowed. You'll get a ticket from the chemistry cops. So we fix that by balancing equations. And to do that, we'll add coefficients in front of all of these, or the formulas that need coefficients. Well, we don't quite know what that means yet. And I want to take a look at, I want to use a sim here. So I'm going to go to share my screen. And let's go to my equation balancer. Put this down. All right, so what I have here is a simulation, and this is from Colorado EDU. And I'm going to put a 1. So I'm going to take nitrogen gas. I'm going to react that with hydrogen gas to form ammonia. Now notice nitrogen is by itself. That indicates it's in its elemental state. And it's diatomic, so we have to have N2. Over here, hydrogen is by itself. That indicates elemental, so it's diatomic. So I have H2, and the formula for ammonia is NH3. I'm going to put a 1 in front of each of these. So here's my diatomic ammonia. Here's my diatomic hydrogen. And then ammonia is 1 nitrogen with 3 hydrogen. So I'm going to add my scales. And this is showing my nitrogen on my left and my nitrogen on my right. This is showing my hydrogen on my left and my hydrogen on my right. And you'll notice that the scales are not balanced. So I have more hydrogen over here. I have 3 hydrogen here, and I have 2 here. So I'm going to increase this. Now I have increased my hydrogen. And you'll notice when it did that, it added it by molecule. It added another molecule. So I couldn't just write, I couldn't change this to 3 because that's not the way that hydrogen forms. All right, well, now I have 4 on this side and I have 3 on this side. So that's not going to work. The other thing is I have less nitrogen on this side and I have hydrogen on this side. So let's increase this to 2 and see where we're at. Okay, now my nitrogens are balanced. I've got 2 nitrogen over here. I've got 2 nitrogen over here. But now I have more hydrogen on this side and I have less hydrogen on this side. Well, if I increase this, now I'm balanced. But you'll notice every time we change the coefficient, I had to add a whole molecule. So I didn't just add a nitrogen. I didn't change this to N2H3. We can't do that. We have to add it by molecule. And that's one of the big sticking points for balancing is students want to just rewrite the formulas. You can't do that. Ammonia is always 1 nitrogen with 3 hydrogen. And so when I increase this coefficient, I'm adding another molecule of that. All right, let's do another one. Let's look at methane. A little more complicated. So I have methane is CH4. I'm going to add 1 of those. So here's my carbon, and I've got 4 hydrogen. Oxygen is diatomic. That is O2. Carbon dioxide is a carbon with 2 oxygens, and of course, water is H2O. So those are my formulas. So now I want to balance. One of the things we're going to see is you usually want to save hydrogen for last, or you want to save the compound. So what we'll see here, you want to save hydrogen or oxygen for last. On this side, oxygen shows up 2 places. Because I have oxygen here and oxygen here, I'm going to save that for last. When I start off, my carbon's already balanced, but my hydrogen isn't. So I have 4 hydrogen on this side and I only have 2 on this side. So I'm going to increase that, and that's going to balance my hydrogens out. So now my carbon's balanced, my hydrogen's balanced. But on this side, I have got 1, 2, 3, 4 oxygen. And on this side, I only have 2. When I increase this to 2, it adds another molecule of oxygen and it balances me out. So now I have 1 carbon on the left and the right. I've got 4 carbons. 2 times 2 is 4. I'm sorry, 4 hydrogens. Here I've got 4 hydrogens. Here I've got 2 times 2 is 4 hydrogens. And my oxygen, I have 4 on this side. 2 times 2 is 4. Here I have 1 molecule that has 2, so this has got 2. Here I've got 2 that each have 1, so that's 2 times 1. So I have 1, 2, 3, 4, and I'm balanced. All right, so let's go back to our handout. And let's start off by saying the reason that we balance, the purpose is to satisfy the law of conservation of matter. Law of conservation of matter. Matter cannot be created or destroyed. So we have guidelines, and the first and most important guideline, so rule number 1, is that we add coefficients, or actually, let's say change coefficients. Never formulas. The best way to make sure that you don't do this is to always write now. For these 3, our formulas are already written, and so it's really not going to be too tough of a challenge. But when we get down here, I'm going to show you the right way and wrong way to do this. And we're going to kind of go back to rule number 1. By the way, this will probably end up being 2 videos. Just looking at the pace and where we're at, I'm thinking I'll probably split this into 2. So one of the things you might want to do is you might want to do element tallies. So you might want to make a zinc, a hydrogen, and a chlorine list over here, and a zinc and a hydrogen and a chlorine list over here. This is just a suggestion. Some people can balance without doing this. Some people, this really helps. So if I look on this side, I have 1 zinc, I have 1 hydrogen, and I have 1 chlorine. On this side, I have 1 zinc, I have 2 hydrogen, and I have 2 chlorine. So in order to balance this, I'm going to have to increase these to 2. I'm going to have to get these up to 2. Well, I can do that by adding a 2 in front of my hydrochloric acid. So if I do that, now my new numbers, I have 1 zinc, I have 2 hydrogen, and I have 2 chlorine. And that fixes my imbalance. Now, you might have said, well, why don't I just change to ZnCl and change that to H? Because then you don't have zinc chloride and you don't have hydrogen gas. These have to stay the same. So we changed the coefficient. All right, rule number 2 is to keep your polyatomic ions together. Keep or group your polyatomics. This is the reason why in the last chapter I had you guys memorize polyatomic ions so that you could look at them and recognize, oh, hey, that's a polyatomic. So for example, when you see this, you should go, oh, I know that. That's sulfate. I've got sulfate over there and I've got sulfate over there. So I should keep those together. So that when I make my element bank over here, I've got hydrogen. Now I could write sulfur and I could write oxygen, but it would be better to do SO4. I've got barium and I've got chlorine. And over here, I've got hydrogen, I've got chlorine, I've got barium, and I've got sulfate. Probably should have kept them in the same levels, but that's okay. All right, so on the left, I have 2 hydrogen. I have 1 sulfate. I have 1 barium, and I have 2 chlorine. In fact, let's just do that. Let's do SO4. Here I've got barium, and let's do Cl here. Okay, on this side, I have 1 hydrogen. I have 1 chlorine, I have 1 barium, and I have 1 sulfate. So that means that I'm going to need more hydrogen, and I'm going to need more chlorine over here. I have to get this up to 2, and I have to get this up to 2. Well, if I put a coefficient of 2 in front of my hydrochloric acid, that now makes my new counts are 2, 1, 1, and 2. And so I'm balanced. All right, guideline number 3 is to balance a substance. This is usually a cation. Or I could say substances that only appear once. Once on each side of the equation. All right, so here's another example. I've got aluminum carbide plus water gives me methane plus aluminum hydroxide. And when I look at this, I've got aluminum, I've got carbon, I've got hydrogen, and I've got oxygen. Aluminum, carbon, hydrogen, and oxygen. But look, hydrogen appears in 2 of these compounds on this side. So I'm going to save that for last. I have aluminum that appears once, and I have carbon that appears once. And so I think the easiest thing to do would be to balance aluminum and carbon first and save hydrogen and oxygen for last. In fact, that's guideline number 4. Guideline number 4 is to save hydrogen and or oxygen for last. Usually we'll want to do that. All right, so if I've got 4, I've got 4, 3, 2, and 1, and over here I have 1, 1. Oxygen, I'm going to have, remember when I have OH, it's like saying I have OH, OH. I have 3 of those. I'm going to have 3 oxygen, and I've got 4 hydrogen here, and I've got 3 here, so I've got 7 hydrogen. All right, let me make sure that math makes sense to you. Okay, so the easiest thing to do is going to be to balance, because I have aluminum, aluminum, carbon, carbon. I'm going to need 4 aluminum on this side, so let's put a 4 here. I'm going to need 3 carbon, so let's put a 3 here, and let's see how that changes my totals. So now I have 4 aluminum. I've got 3 carbon. I have, if I multiply 3 times 4, I have, well, let's do the oxygen first. So I've got 3 of these, and that's 4 times. So I'm going to have 12 oxygen. And then my hydrogen, I'm going to have to do, I've got 3 of them here. So I'm going to have 12 hydrogen here, and I'm going to have 12 hydrogen here. So I'm going to have 24 hydrogen. So my aluminum are balanced, my carbon are balanced, but my hydrogen and my oxygen aren't. Well, if I put a 12 in front of my water, now I have 12 oxygen, and I've got 24 hydrogen. So that's how I have to balance that equation. All right, yeah, I'm pushing the 15-minute mark, so we're going to hit pause, and we're going to do some practice problems, and we're going to work on doing some of these word equation into formula equations. All right, stand by for part 2.